Hey there, hi there, ho there, welcome back. 11. Let's take it to the coast. Let's talk about some coastal hazards. So we're going to talk really about the interaction between land and water, which can be a pretty hazardous place, for lack of a better term. The solid earth meeting liquid water. There's a lot of impact of geology. There's interacting between these two worlds, and bad things happen. So let's talk about that, shall we? Maybe one of these days. Come on. There we go. So why is this geology? Well, this is ocean. This is water stuff. What's going on there? Why is this geology? Again, continental and oceanic processes, they converge at this location, right along the coast. And it doesn't have to just be oceans and coasts. It can be lakes as well, larger lakes as well. But you get these continental and oceanic processes converging to produce landscape that are capable of very rapid change. And as such, hazards occur. Coastal topography, the terrain, is greatly influenced by plate tectonics. There are two types of boundaries we'll look at: tectonically passive boundaries or margins. These are coasts that are not near plate boundaries. And we have tectonically active margins. These are coasts that are on or near plate boundaries. So being on or near a plate boundary or away from a plate boundary greatly affects the topography there, and all of that is due to plate tectonics. So let me give you an example. So here is the North American continent. Just focusing on the United States here, on our west coast, we are right along the plate boundary. From Washington down through California, that's right on or near the plate boundary, the North American plate boundary. Whereas if you look at the east coast of the U.S., that is nowhere near the plate boundary. The plate boundary is way out here in the middle of the Atlantic Ocean between us and Africa. So the east coast of the U.S. is known as a passive continental margin. It's tectonically passive. Plate tectonics really isn't playing too much of a part there. There's no interacting of plates there. Whereas on the west coast, it is considered an active continental margin. It's tectonically active, meaning it is right on or near a plate boundary, the west coast of the U.S. Therefore, you do have a lot of interacting between plates, and that does dictate the type of topography, the type of terrain that you would find at that location. So the west coast looks visually different than the east coast. So we'll talk about these different types of margins. But for most of North America, it's like that. Along the western whole of the North American plate, you can see a lot of mountains. On the eastern edge of the North American continent, there's really nothing. It's more flat. So let's just touch on that for a little bit. So again, an example of a tectonically passive margin, would be the U.S. East Coast. There is no plate boundary on the U.S. East Coast. It's way out in the middle of the Atlantic Ocean. It is what the East Coast does have is something called a very wide continental shelf. All right. So the continental shelf is the bit of the continental crust that sticks out into the ocean. However, it's been weathered and eroded down a little bit, so it is covered by a little bit of ocean. So when we say wide continental shelf, this could be up to a couple hundred miles wide before it really drops down deep and starts to become oceanic crust. So passive margins, not near a boundary, have typically a very wide continental shelf. They also typically have very sandy beaches and structures called barrier islands. So let me show you some images. So this is a tectonically passive margin. So this would be typical of something you might see on the East Coast, away from a plate boundary. Very sandy beaches. If you look in the distance, very flat. All right, has a very broad, very wide continental margin. So the ocean is relatively shallow, even up to a couple hundred miles out before it really drops off. Again, one type of landform you might see near tectonically passive margins are going to be barrier islands, these kind of sandbars that naturally form kind of away from the typical coast. That could be anywhere from 10, 20, 30, 50 miles away, but it tends to kind of form these sandy barriers that do protect the waters behind it. So these are some barrier islands here. More on that a little bit later. This is what a barrier island kind of looks like from above. But in any case, tectonically passive, very gentle slope. You know, there's not rugged terrain, very gentle sloping terrain, sandy beaches. That's typically what you see at a passive margin. But then you have the opposite of that, the tectonically active margins. For example, the west coast of the U.S. It is right on or near a transforms and or convergent boundary, depending on where you're at. It has a very short continental shelf. So again, here's another map of North America. You can see the continental shelf, the shallow part of the continental crust sticking out from the dry continent. It's still part of the continental crust. It's just been kind of weathered and ground down a little bit by the ocean. Excuse me. But you can see on the west coast, it doesn't really have much continental shelf at all. Very broad on the east coast. It's a passive margin. There's not much there on the west coast. So what that's saying is it goes from the coast and sometimes coastal mountains, a very rocky shoreline, and then it just drops off into the deep ocean not too far out. So along the west coast, it's a lot of sea cliffs, rocky shoreline. This is typical of what you would see at any tectonically active margin. So very rugged. We have mountains, not much beach at all, a lot of rocks. And so the continental shelf sticks out maybe 5, 10, 15 miles, and then it drops off to the deep ocean. So what's the concern? What's the big whoop here? So why is this a hazard? Well, 53% of the U.S. population lives in coastal counties. That's a county that touches the coast in some way, shape, or form. These counties account for about 17% of the total U.S. land area. So more than half of the country, the U.S., lives right on the coasts, wherever that may be. Some of the more serious coastal hazards include strong coastal currents, things called rip currents and tidal currents. More on that later. Coastal erosion, so the waves battering the sea, eating at the cliffs. So you have property damage, homes falling into the ocean. Humans have to adjust as well. Storm surge, from hurricanes or other major storms that can cause deaths and property damage, and obviously tsunamis. So all of this meets right where we're talking. So now you got not only the hazards associated with land, but also the hazards associated with the ocean. Thinking back to some of the other things that we talked about, earthquakes along margins, landslides in California, which is obviously on the west coast, which is a tectonically active margin. So it's pretty. That's why people live on the coast. It's nice. The climates are usually a little bit more moderate. It's also a little bit more dangerous. Anywho, let's pause there, and when we come back, we'll talk about some of these processes that drive the geology along the coasts. We'll see you back here in just a second.